Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular paper is June 2019, paper 3, Foundation Tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. Circle the value of the digit 2 in the answer to 5,200 divided by 10. Well, 5,200 divided by 10, we're just going to kind of scratch a 0 off of there, aren't we? So that's going to give me 520. So what is the value of this 2 in the 520? Well, it's 20, isn't it? It's going to be that one there. Question 2. Solve x minus 8 is equal to 5. Okay, so if we start with x minus 8 is equal to 5, this is an equation, and x we need to solve. We need to try and get x by itself. We can do that by adding 8 to both sides. You can see on this side that minus 8 is going to cancel with the 8, and that's going to leave me with just x on the left. On the right, 5 plus 8, that's 13. So that's our answer, x is equal to 13. Is that one there? Question 3. Circle the fraction that is equal to 2 1/4. Okay, so 2 1/4 is what we call a mixed number. It's made up of a whole number part of 5, and it's got this fractional part here, isn't it, which is 1/4 1/4. Okay, now all the other answers underneath are written as improper fractions, so rather than mixed numbers, so it's how many of those quarters we've got all together. Now we can work that out. We can turn a mixed number into an improper fraction quite easily. We can just take these two numbers here and multiply them together. So 2 times 4 is equal to 8, and then add on the 1, that's equal to 9. So 2 1/4 is the same thing as 9 quarters. Okay, the other way you can visualize it is if you have like 2 whole pizzas divided into quarters and another quarter of a pizza. Very badly drawn quarter pizza there. But you can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 quarters altogether. Okay, so it's that one there. Question 4. Circle the expression which means x divided by y. Well, x divided by y is just this one here, isn't it? X over y. That's what divisors are. That's why the division symbol is this. Those 2 dots here and here represent the 2 things that you're dividing. That's why the symbol is what it is. Question 5. Put these numbers in order from smallest to largest. Now, we've got a bit of a mixed bag of things here. We've got 3 fractions and then we've got a decimal number on the end. Okay, now when you've got things written in different forms like this, they're really difficult to compare. So the first step is to get them all into the similar sort of type of number. So we could all convert them all into fractions with the same denominator. So we could make them all into 40ths, or maybe over hundredths, or we could turn them all into decimals. Now this is the calculator paper, So I think the easiest thing is going to rewrite these each as a decimal and then compare them then. Okay? So let's just tap in 31 over 40 into the calculator. If I press the symbol to decimal button, that's going to give me it as a decimal, so I'm going to get 0.775. 0.775. Okay, the next one, 3/4, same thing, 3 over 4 as a fraction. What's that as a decimal? That's 0.75. Now it's probably a good idea to write them with the same number of digits. So you can see I've got like 3 after the decimal point here. So let's do the same thing. Let's make this one 3 after the decimal point. So I'm going to add an extra 0 in there. Just going to make them a bit easier to compare. 7/10. Well, I know that one already. That's just 0.7, isn't it? And again, I'm going to pad it out so it's got 3 digits as well. And then I've got 0.725. Which is already like that. Okay, so now they're written like that, it's really easy to put them into rank order. So the smallest is that one, then the next biggest is going to be that one, and then the next biggest is that one, and then the next biggest is that one. Now I like to write them down in the same form as they give me, so rather than writing those decimals, I'm going to rewrite the things that they gave us. So the smallest one then is 0.700 or 7/10. Just going to write down in the same symbol that they gave me. Then the next biggest was 0.725. Next one was 3/4. And then finally I've got 31 over 40. Okay. Question 6. Josh downloads album A. A has 11 tracks. Each track on A costs the same. The total cost of downloading A is £8.80. Josh also downloads album B. B has 14 tracks. Now part A says work out the total cost of downloading B, assuming each track costs the same as a track on A. Okay? Right, so this has got a few steps to it, isn't it? First off, let's go back up and look at album A. Now album A had 11 tracks, and it costs £8.80. So we should be able to, from there, work out the cost of one track. Cost of each track, that's going to be the total cost, £8.80, divided by the number of tracks, which is 11. So what's 880 divided by 11? Reach for the calculator. £8.80 divided by 11. That comes out to be 80p, 0.8, which is 80p, isn't it? So it's 80 pence a track. I'm going to rewrite it as 0.80. And now Josh also downloads album B. B has 14 tracks. Okay, so the cost of B then is going to be the 14 tracks times the cost of each track. So 14 times 0.8, that comes to 11.2, which is £11.20, isn't it? Okay, so answer to 6A is going to be £11.20. 6B says, in fact, compared to the cost of each track on A, the cost of 6 tracks on B is more by 5p each, and the cost of 8 tracks on B is less by 5p each. What does this tell you about your answer to part A? Tick one box. Is the total cost going to be less than my original answer? Is it going to be more than my original answer? Is it going to be the same as my original answer? Okay, well, let's do this one step at a time. We knew the original cost was, what we worked out was £11.20 or something, wasn't it? Now here it says the cost of 6 tracks is going to be more by 5 pence. So this is going to have an impact on the overall cost of the album, isn't it? It's going to be 6 lots of 5 pence more expensive. Sorry, 5 pence, not 50 pence. So 6 lots of 5 pence. What's that? That's 30p, isn't it? So that's going to add 30 pence to the overall cost of the album. Okay, so that's going to be an addition. But then we've got the cost of 8 tracks being 5 pence less. So our 8 tracks at 5p each. That's 40 pence, isn't it? So that's going to be a saving of 40 pence. So if we're going to add 30p and then take away 40p, overall that is taking away 10 pence, isn't it? So overall it's going to be 10 pence cheaper than it was. So the total cost is less than my answer to part A. Question 7. The pictogram shows information about the houses in a street. Each house has 3, 4 or 5 bedrooms. And we've got a pictogram here, and we've been given a key at the top, and it says one little symbol like this, that's worth 2 houses. Okay, so if you have a look at 3-bedroomed houses, we've got 1, 2, 3, 4 houses and a half a house. So 4.5 houses. So that is going to represent altogether 4 times 2 is 8 plus half times 2 is 1. So that's 9 houses altogether, isn't it? So that's 2, 2, 2, 2, and that one is a 1, giving you 9 altogether. Okay, 4-bedroom houses, got 5 complete houses there. 5 times 2 is 10. And then these 5-bedroom houses, again, we've got 1 complete house, which is worth 2, and a half house, which is worth 1. So that's altogether is equal to 3. So in total, how many bedrooms do all the houses have altogether? We just need to add all those up then now, don't we? So 9 plus 10 plus 3, that comes to 22. So that's my answer. 22 bedrooms. Question 8. 4 positive whole numbers add up to 84. One of the numbers is a multiple of 17. The other 3 numbers are equal. What are the 4 numbers? So this is a bit of a puzzle we're going to have to work out, isn't it? We've got 4 numbers that add up to 74. That's the first clue. One of the numbers is a multiple of 17. That's the second clue. And then we've got the other 3 numbers are equal. That's the third clue. So we have to use these 3 clues to work out what the numbers are. Okay, now I think the easiest one to start with is probably the green one. One of the numbers is a multiple of 17. So what does that mean? What's the possible answers then? Well, the multiples of 17 are 17, 34, 51, 60, 68. And then it's going to be 85, which is too big. Okay, so these are the 4 possible multiples of 7. So one of the numbers could be a 17 or a 34 or a 51 or a 68. Okay, now the other 3 numbers are equal, and these are whole numbers, aren't they? So that means that whatever the first number is, when I take that away from 84, what's remaining needs to be a multiple of 3, so I can divide it equally by 3 and find my 3 other numbers. Okay, so what we're going to do is we're going to try each of these numbers in turn, and we're going to see what we get when we subtract it from 84, see if it's a multiple of 3 or not. Okay, so what's 84 subtract 17? That is going to be 84, 74, 60, 67. Is that a multiple of 3? No. It's not a multiple of 3, is it? Because 60 is a multiple of 3. 30, 60, 63, 66, so 67 is not going to be. Okay, so I don't think that can be the answer. What's the next one? Let's try 84 subtract 34. What would we get then? So 84 subtract 34, that leaves me with 50. Now is 50 a multiple of 3? No, I don't think so. There is actually a quick way of working out if a number is a multiple of 3. You just kind of add all the digits together and see if that's a multiple of 3. So for the last one, 6 plus 7 is 13, and I know 13 is not in the 3 times table, so nor can 67 be. With this one, 5 plus 0, that's 5. 5 is not in the 3 times table, so nor is 50. Let's do the next one. 84 subtract 51. What's that then? So that's going to be 33. Now 3 plus 3 is 6. 6 is in the 3 times table, so I think that one is fine. I think that one is the one that's going to be. Okay, but let's just check the last one. 84 subtract 68. What's that then? That's going to be 24. 16, isn't it? 16. 1 plus 6 is 7, and 7 is not in the 3 times table, so that one can't be the solution. Okay, so it's going to have to be 51. 51 is the one it has to be. So and that leaves me with 33 left over. So if we now divide 33 by 3, it's going to tell me what each one is for the 3 remaining numbers. So 33 so divided by 3 is 11. Okay, so that means my 4 numbers must be it's going to be the 51 and then 11, 11 and 11. Now at this point you might just want to double check your working by adding your 4 numbers back up and just double check that you do get 84. 51 and 11 and 11 and 11 does add up to 84, so I'm pretty confident we've got it right. Okay, good job, let's move on. Question 9. Jim wants to buy 10 rolls of wallpaper. He sees these prices. So he can either buy a single roll for £12.50, he can buy a pack of 3 rolls for £34.50, or he can buy a pack of 5 rolls for £58.75. Which is going to be the cheapest way then of purchasing 10 rolls? Okay. Now, you would think that probably the cheapest way is going to get like the biggest packs. So like two lots of 5 makes 10. So you might think straight away it's £58.75 times 2. That would be the answer. But I think it's probably a good idea just to work out from each of the multi-pack deals what the cost of each roll is, because it's not always the case. Sometimes the multi-pack deals end up being worse than buying single items. So let's just work out the cost of each one first. So well, obviously a single roll costs £12.50, so no surprise there. So if 3 rolls cost £34.50, what's 1 roll then? So let's just divide that in the calculator. So £34.50 divided by 3, what's that? 34 by 3, that comes out to be £11.50. Okay, so that is a bit cheaper than buying the single rolls. And the pack of 5 at £58.75, what's that then? So £58.75, if we divide that by 5 to find the cost of 1 roll, £58.75 divided by 5. See, there you go, £11.75. So it's not always best to buy the pack of 5 because it ends up being more expensive. Okay, so it's not just going to be cheapest necessarily to buy the 2 5-pack rolls. So what other possibilities are there? So if we label this 1, 3 and then 5, then what we could do, we could have what possible combinations? We could either have 2 lots of the 5-pack roll, which we said that gives us 10 rolls, or we could have 3 of the 3 packs and then have 1 of the 1 packs. That's a possibility as well. Are there any other possibilities? I suppose we could have a 5-pack, a 3-pack and 2 singles, but I'm not going to think that is going to be any cheaper, and I don't think all the single rolls are going to be any cheaper. I think these are the 2 ones we need to just double check and find out what they are. So what's 2 lots of the 5 then? That's going to be 2 lots of £58.75. What does that come out to be? £58.75 times 2, that gives me £117.50. Okay, and then 3 lots of the 3, so 3 times £34.50 plus £12.50, one of the single runs. What does that come out to be? So 3 times £34.50 plus £12.50. That comes out to be £116, so that's just slightly cheaper then, isn't it? Okay, so that seems to be the better deal. So getting 3 of the singles, 3 of the 3 packs and 1 single. And that's going to necessarily be cheaper than the other options, isn't it? Because we know that the 3 packs are the cheapest overall. So let's just state that cheapest price is £116. Okay. Question 10. In rectangle ABCD, triangle ABE is equilateral, triangle CDE is isosceles with CE equal to DE. Okay, now with these questions I always just double check that the information that's given in the text above the diagram is actually in the diagram, so that is nice and clear. So in rectangle ABCD, triangle ABE is equilateral. Where's triangle ABE? ABE. We're talking about this triangle here. Okay, now that isn't marked at the moment as equilateral, so that information isn't on the diagram, so it's always worth reading that. If you just missed it out and was looking at the diagram, you would be a bit stymied here to be able to answer it. Okay, so let's just mark that on. So if it is isosceles, so if it's an equilateral triangle, then these three sides are all equal to each other, and these angles are all equal to each other, aren't they? And actually those angles are all 60 degrees. Okay, and then the next thing that it says is that triangle CDE is isosceles with CE equal to DE. Okay, where's CDE? CDE, we're talking about that triangle there. Now that one has been marked, isn't it? Because they've marked the two little lines there showing that those two sides are equal. Okay, so that has been added to the diagram already. Okay, so what do we need to do? We need to work out the angle here, this x here. So how are we going to go and do that then? This is a rectangle, isn't it? So rectangles have sides or angles that are right angles, so that's going to be a right angle there. So if that part of the angle is 60, then what is left over here then? That's going to be 90 minus 60. That's going to be 30 degrees, as is this over here. That's also going to be 30, isn't it? Because it's kind of, well, it's got a line of symmetry going down the middle. So that's 30. So in this, and then let's have a quick look at this triangle here then. Triangle ADE, this triangle. Now the angles in a triangle add up to 180 degrees, don't they? Okay, so if the angles in a triangle add up to 180 degrees, then this angle here is going to be, what is it? It's going to be 180 minus those other two, isn't it? So the 30 and the 65 added together. If you take that away from 180, it's going to leave you with that angle that's there, isn't it? So 30 and 65 is 95. Take that away from 180, that's going to leave you with 85 degrees. Okay, so that's what this angle is in here. It's 85. Now you can have exactly the same argument over here. Because this is isosceles, then this is also going to be 65. And so then, well, we found it. Then this is going to be 85 as well then, isn't it? Okay, so x is 85. Question 11. Complete the number machine. So I've got A, and it's fed into the first box, and then something happens to it, we don't know what, and then something comes out and it's times by 5, and we get 5A plus 10 come out of it. Okay? So what must we have done in that box there in order to get 5A plus 10 out again? Okay, well let's just try and work backwards. If I've got 5A plus 10, now you can factorize that, can't you? 5 goes into 5A and 5 goes into 10. So that's the same thing as 5 lots of A plus what? A plus 2, isn't it? 5 times A is 5A, 5 times 2 is 10. Okay? So this 5 here is coming from there, isn't it? That's where the times 5 comes from. The A comes from what we started with here. So what must happen in that box then is this bit here, plus 2. So we start with A, we add 2 to it, and then we multiply it by 5, and we get 5A plus 10. Okay, so what am I going to write in that box? I'm going to write plus 2. 11b says write down the output y in terms of x. Okay, So what happens? So we're going to take this x to start with. So we're going to start with x, and then we're going to divide it by 2. So I could write it like that, but actually it's probably going to be better if I write it as a quotient like this, x over 2. So x over 2 is what I do first, and then I add 4 to it, plus 4, and that gives me my output y. Okay, so what is the output y in terms of x? Then y then is going to be equal to x over 2 plus 4. So here's my y, here's the x I got started with, then I divided it by 2, and then I added 4. Okay, so y equals x over 2 plus 4. The first 4 triangular numbers are 1, 3, 6, and 10. Circle the next triangular number. Okay, so you probably know this already, but let's just draw these out. So the first triangle number is just like a 1, like that 1 dot. And then the triangle numbers are the numbers when you have that number of things, you can arrange it into a triangle. So I know that 1 looks a bit weird because it's just by itself, but you can see quite clearly that I can arrange those 3 things into a triangle. So think about all those games that you play with a triangular number of balls or pins, like pool or 10-pin bowling. They're all the sort of things that you're looking for, aren't they? So 6 things you can arrange into a triangle, then 10-pin bowling. Looks like that. That's going to be the next number of things. And then any pool players out there, you can get the next row. Well, basically what you're doing each time is you're adding 1 more than the row before, aren't you? So to get the next triangle number, I'm going to add another row of dots to my existing triangle. Okay, I'm going to add 5 more, which you'll know if you play pool, that you've got 15 balls in the triangle when you're playing pool. So the next number is 15. Write down all the prime numbers between 40 and 50. Now, maybe you know all the primes between 40 and 50, in which case, good job, you just need to list them and then job done. If you don't, then maybe you can write down all the numbers between 40 and 50 and then get rid of the ones that are not prime somehow. So 43, 44, 45, 46, 47, 48, 49, and 50. Okay, so they're all the numbers between 40 and 50. Now, prime numbers are prime numbers that don't have any other number as a factor. Okay, so if it's got another number as a factor, it's not a prime. Okay, so we can just kind of get rid of some numbers straight off. If you think about all the multiples of 2, all the multiples of 2 have got 2 as a factor. So basically any even number is not prime, so we can get rid of all the evens straight away. So that's more than half of my choices gone already. Okay, that's good going. And then let's see if we can get rid of some other multiples. So what are the multiples of 3? So 30, 33, 36, 39, 42, 45, 48, and then we're over the top. So 45 is a multiple of 3. Multiples of 4 are going to be multiples of 2. Multiples of 5, they're all gone, 40, 45, and 50. Multiples of 6 we've already done. Multiples of 7, 7 times table, 35, 42, 49. Okay, so that one's gone. That's a multiple of 7. 8s don't care about because we've already done. 9s, 45, we've already done that. 10s, 11s, 44 we've already done. 12, 13, 13, 26, 52, that's too big. 14, nope. 15, nope. 16, 17, 17, 34, 51, nope. 19, 19, 38, no, that's going to be gone as well. 20, I think we've got them all, haven't we? Okay, so there we go. I think that's all the multiples all done. So what have we got left? We have got 41, 43, and 47. Circle the correct statement. Is 1/3 less than or equal to 30%? Is it equal to 30%? Is it less than 30%? Is it not equal to 30%? Well, 1/3, if you do 1 divided by 3 on your calculator, you'll get 0.333 or 0.3 reoccurring. So as a percentage, so that's going to be 33.3 reoccurring percent. Okay? So clearly it's not equal. Okay? Is 33.3% less than or less than or equal to 30? No, it's bigger, isn't it? So it's not that one, and it can't be that one either. So the only thing it can be is that one there. 1/3 is not equal to 30%. Question 16. Which shape must have rotational symmetry? Circle your answer. Now what this question is missing is diagrams. You haven't got any pictures of any of these things. So let's quickly sketch these in. So that's an isosceles triangle, isn't it? A trapezium. What does a trapezium look like? Okay, that will do. So there's my trapezium. A kite. I have to draw this one with a ruler because it wouldn't let me draw it with the auto shape. It kept drawing a rhombus and not a kite. So let's draw it properly with a ruler. And then the parallelogram. I've got a shape for one of those. Okay, so if they haven't got these diagrams in your exam paper, then just draw them in. Okay, so then you can have a look at them. You can imagine them then. So which shape must have rotational symmetry? Now the isosceles triangle is not going to lay on top of itself when you rotate it. When you're looking at rotational symmetry, you've got to imagine that you can put a pin in your diagram and spin it around. And which ones are going to look the same in as you turn it 360 degrees around. Now the isosceles triangle is going to have rotational symmetry of order 1 because it isn't going to look the same until it gets all the way back to where it started from. Same with the trapezium, same with the kite. Parallelogram though is going to have rotational symmetry of order 2. It's going to look the same upside down as it is the right way up. Okay, so which one must have rotational symmetry? It must be the parallelogram. Question 17. A shop sells ice creams. Each ice cream has 2 scoops. The possible flavors are vanilla, strawberry, chocolate, and mint. The scoops can be the same flavor or different flavors. So list all the possible options for the 2 scoops. So with these, the easiest thing is to keep one the same and then rotate through the others. So let's put vanilla in scoop 1 to start with, and then we can have also vanilla in scoop 2, can't we? So vanilla. We could have vanilla strawberry, we could have vanilla chocolate, we could have vanilla mint. Okay, so we've done all the options there involving vanilla. So let's get rid of the vanilla and let's move to the next flavor, which was strawberry. Now we've already done strawberry vanilla because that's the same thing as this one up here, isn't it? Vanilla strawberry. So we don't have to do that one again. So we don't have to think about vanilla anymore. But we could do strawberry if you really like the strawberry. You could do strawberry chocolate, or you could do strawberry mint. Okay, now they're all my strawberry options. So let's move on now to chocolate. Now again, we've already done chocolate vanilla. It was here, and we've already done chocolate strawberry. It was here. So we don't have to worry about those options here because you can just turn the ice cream around, can't you? It's the same thing. So we're going to skip those first 2. So the only options we've got left really then are chocolate and chocolate mint. Okay, and then finally we've got our mint thing. Now we've done mint with everything else. We've got mint chocolate already, we've got mint strawberry already, we've got mint vanilla already. The only thing we don't have is mint. Okay, so that's it. That's my final amount. So how many is that then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different combinations. Okay, so there's 10 different combinations that you could have. Question 17b says, in 1 hour the shop sells 180 scoops of ice cream. The number of scoops of each flavour is shown in the table. Okay, so 45 scoops of vanilla, 75 scoops of strawberry, and so on. Now we need to show this information in a pie chart, but before we do that, we need to work out what angles and things that we're going to use. So before we get onto the pie chart, we've got some work to do on the table first. Now, we've already told what the total was. The total number of scoops was 180, wasn't it? Okay, so 45 plus 75 plus 50 plus 10, that's 180. Now, what we want to do is we want to take those number of scoops and turn them into the number of degrees that we need to draw on the pie chart to represent them. Now, in a full turn, you've got 360 degrees, haven't you? So the angle that we're going to use to show this needs to add up to 360. Now you'll probably notice straight away that 360 is twice as big as 180. So that means we can use 2 degrees to represent 1 scoop of ice cream that was sold. Okay, so that makes it very easy to work out the various angles that we need to use. We just need to double up then each of these. So my 45 scoops of ice cream, if I'm using 2 degrees per scoop, that's going to be a 90-degree angle that we're going to use. Strawberry, 75 times 2, that's a 150-degree angle. Chocolate is going to be a 100-degree angle. And mint is going to be 20 degrees. Okay, so moving on to the pie chart now, we've been helpfully given one of the lines to start off with. So this is going to be like one of the lines for our vanilla sector. Now vanilla was a 90-degree angle, so if we lay our protractor along that starting line with the centre of protractor right at the end of the line in the centre of the circle, we should be able to count around to 90, draw a mark, then remove the protractor, and then draw on our 90-degree angle line. Okay, so that was 90 degrees, wasn't it? Okay, so this was then vanilla. Right, now the next angle we need to draw is 150. So again, we're going to take the protractor, but we're going to lay it on top of our newly drawn line, so the second vanilla line, and we're going to count around to 150. We're going to make a little mark, remove the protractor, and then join up the line that we made. Okay, so 150. It's going to be there then, isn't it? Okay, so then that is my strawberry section. That was 150 degrees. The next section was our chocolate degree thing, and it was 100 degrees. So again, we're going to lay the protractor along our last drawn line with the center of the protractor at the center of the circle. We're going to count up to 100, make a little mark, remove the protractor, and then we can draw our line in. Okay, so that was my chocolate section, and that was 100 degrees. Okay, and now the mint section, it kind of draws itself. Okay, so it's just the leftover part, isn't it? But you might just want to double check that that angle there is 20 degrees. So if you measure it, and it should be there or thereabouts. If you're like a degree either way, it's not going to make much difference. But just double check that it's there or thereabouts for 20. Okay, and that's that. We're done. On the grid, draw an enlargement of the triangle with scale factor of 1/2. Okay, now there's no center of enlargement given, so we can just draw this enlargement anywhere on the grid. We're not dictated by the center of enlargement. So what do you do to draw an enlargement? Well, you need to measure these. So that length there is 4 squares, isn't it? Let's take the measurement of the tip above the base. That's probably the easiest one to measure. That is 1, 2, 3, 4, 5, 6 units up. So if I'm going to multiply those distances by a scale factor of 1/2, 4 times 1/2 is 2. So I'm going to get a line which is 2 units along rather than 4. 2 units. And 6 times 1/2 is 3. So the tip of my triangle is going to be 3 units above. So let me just put that in as a dotted line. 3 units is my center of my triangle, the perpendicular height of my triangle, I should say. Okay, now let's just draw the 2 sides on. Okay, so only in the crazy world of mathematics can you get an enlargement that is smaller than the original shape. But there we go. Scale factor of 1/2 is going to end up smaller. Question 19a. Simplify fully 3a squared plus 7a plus 3 minus a squared plus 8a minus 4. Okay, so this is a matter of collecting like terms together. Okay, now terms are alike if they are followed by the exact same arrangement of letters. So we've got 3 different types of term here. We've got terms in a squared. So we've got 3a squared there, and we've got a minus a squared there. Now notice when I highlighted a squared, I highlighted the symbol that was in front of it, because that negative sign belongs to the a squared. Then I've got a plus 7a and a plus 8a. And then the final, so I've got 2 terms in a. And then finally I've got 2 numbers, okay, or constants we sometimes call them. I've got a 3 and a minus 4, okay? So we're going to collect those together, one after the other. So 3a squared minus a squared. If I've got 3a squared and I take away a squared, that's going to leave me with 2a squared. So my 2 yellow terms becomes 2a squared. And then I've got 7a plus 8a. 7a plus 8a together, well, that's just going to give me 15a. Okay, so my 2 green terms gives me 15a. And then finally, I've got 3, positive 3, take away 4. If I'm at 3 on the number line and I take away 4, I'm going to end up with minus 1. So my plus 3 and my minus 4 gives me negative 1 altogether. So so fully simplified, that is 2a squared plus 15a minus 1. 19b says factorize fully 24y squared minus 20y. Now, when you're factorizing, you're looking for numbers that go into all the terms. But remember, this one doesn't just say factorize, it says factorize fully. So if you've got the word fully on the end, that's kind of screaming out to you that there's actually more than one factor that you need to find here. Okay, so let's start with what we've been given. We've been given 24y squared minus 20y. Now let's have a look at the numbers first off, the 24 and the 20. Can you think of a number that goes into 24 and 20? Well, they're both even, aren't they? So 2 goes into 24 and 2 goes into 20. But actually, it's best to find the biggest number that goes into them. So whilst 2 is a factor, it's not the highest common factor of 24 and 20. The highest common factor is going to be 4, isn't it? 4 goes into 24, 4 goes into 20, and there isn't a larger number that goes into both of those. So I'm going to take out 4 as a common factor, okay? But it isn't just 4 that is common to those 2 terms. I've also got a y squared and a y, so there's also a y that is common to both. So I'm going to take out 4y as a common factor. And then inside the bracket is what you need to multiply by 4y to give you back your original terms. So 24 divided by 4, or 4 times what is 24? That is going to be 4 times 6, isn't it? So if I had 4y and 6, that would give me 24y. But we've got 24y squared, so I need to add another y in there as well. So 4y times 6y is going to give me my 24y squared. And I've got a minus sign, and then I'm going to have a 20y on the end. So 4y times what gives me 20y? Well, 4 times 5 is 20, isn't it? So I think that's just going to be a 5 by itself. 4y times 5 is 20y. Okay, so that's my solution. 4y, open brackets, 6y minus 5. So just remember, if it says factorize fully, then you're looking for more than one factor. So I've got a factor of 4 and a factor of y that I've taken out of here. Question 20, solve x squared equals 196. Now, when you've got an equation you're asked to solve it, you need to try and get like the unknown by itself. Now, at the moment, I've got x squared, and what I want is x. So how do I get x from x squared? Well, you have to square root it. So the opposite of squaring is square rooting. So if I square root x squared, it's going to give me x. But if I square root one side, I need to square root the other. So what is the square root of 196? Let's reach for the calculator. 196 square root. So square root 196, what's that? That's 14. Okay. Now, just take care, because there's actually two solutions to this and not just one. Whilst 14 times 14 is 196, there's also another answer that will give you 196 when you square it as well, and that is negative 14. So if you forget to put plus and minus in there and just write 14, you'll lose a mark. So the solution could be 14 or it could be minus 14, and we can show both of them with this kind of plus and minus symbol here. To the nearest pound, John has £9. To the nearest 50p, Ellie has £6.50. Work out the maximum possible amount of money. There's a couple of clues in here that this is not a straightforward question, actually a limits of accuracy question. This and this to the nearest should indicate that it's going to be a limits of accuracy question, and also where you're being asked about maximum possible or minimum least possible amounts. You're likely to be in a limits of accuracy question. Right, so how do you approach these? Well, I always draw a scale and I mark on the number I'm given, 9. So it's to the nearest pound, so I'm rounded to the nearest pound. So I'm going to use that scale to go £1 up and £1 down. And the values that round to 9 then are going to be the values that are halfway between 8 and 9, up to halfway between 9 and 10. They're all the ones that round to £9, aren't they? Okay, so the boundary of that is going to be £8.50 at the lower end and £9.50 at the upper end. And obviously £9.50 technically rounds up, but it's still the boundary and it's still the value we use in these calculations. Okay, so £9.50 there. So to the nearest 50p, Ellie has £6.50. So again, I'm going to do a similar thing for Ellie. So mark the number I'm given, £6.50, and I'm going up in 50p's here. So the next one up is £7, and the one below is £6. So halfway between the two is going to be there, isn't it? That's £6.25, and halfway between £6.50 and 7 is £6.75. So all the values in between round to £6.50. Okay, now we want the maximum possible value. So the maximum possible means, in this case, if I'm going to add these two together to get their total, aren't I? So I'm going to be adding the upper bounds of these things together. Now, normally in these sort of limits of accuracy questions, I would advise you just to use these maximum values in your calculation. So you should use 9.5 and 6.75 in your calculation when you're finding maximums. But in this case, money, pounds and pence, is a discrete amount. It's not a continuous amount. So actually, the highest amount possible for John is not going to be £9.50, because I would have to round up in that case. It's going to be £9.49. So for this particular case, because it is discrete data, I'm going to eschew my normal advice of going for the maximum value of £9.50 and go for one less, £9.49. And the same for Ellie's £6.75 upper limit. In this case, I would advise using £6.74 instead, because money is discrete and not continuous. Okay, so there we go. So £9.49 plus £6.74. Calculator, what is £9.49 plus £6.74, please? It's £16.23. £16.23. Question 22. Here is a formula. T equals n squared minus 12 over n. Work out t when n is 5. Okay? So let's just write that out again. So we've got t equals n squared minus 12 over n. So what we're going to be doing is we're going to be replacing each of our n's with the value of n. N is equal to 5. Okay? So subbing those in, that's going to give me 5 squared minus 12 over 5 down there then, isn't it? Okay? So what's that? Let's just simplify that a little bit for ourselves. So 5 squared, that's 25 minus 12 over 5 then. Okay, just put that into a calculator just as it is. So 25 minus 12, let's just use the fraction key, 12 over 5. That comes out to be 22.6. Okay. Part B says, why is t always positive when n is negative? Okay. Well, let's remember that t is equal to n squared minus 12 over n. Okay. So if we're saying if n is positive, so if n is negative, if n is less than 0, then n squared is going to be a negative multiplied by a negative, which is equal to a positive, isn't it? Okay? So a negative times a negative is always a positive. So what we're going to get is this bit over here is always going to be positive then, isn't it? Okay, now what about the next part, minus 12 over n? Now if we're saying that n down there is negative, then we're subtracting a negative fraction, aren't we? So t is going to be a positive value minus 12 divided by n, which is negative. Okay? So we are dividing, so we've got a positive value and we're subtracting a negative fraction. Well, taking away a negative thing is the same thing as adding a positive. So this is the same thing as a positive value plus 12 over a positive value. Okay? Because taking away a negative thing is the same thing as adding a positive thing. So therefore, t is always positive. Question 23. In 1 hour, a machine can make 600 nuts or 720 bolts. At 3 p.m. the machine starts working. It makes 900 nuts and then changes to making bolts. How many bolts will the machine make by 8 p.m.? Okay, so let's break this down. So we're starting at 3 p.m., aren't we? That's when we start. So that's when the machine starts, and then it makes 900 nuts. Okay, now we know that it can make 600 nuts in 1 hour. Okay, so if it's made 900 nuts, how long is it going to take to make 900 nuts? Well, if it can make 600 nuts in an hour, then 900 nuts is 1 hour and a half an hour, isn't it? So it's an hour and a half. Okay, so it's going to be, it's going to take a 900 nuts. It's going to take 1.5 hours, isn't it? Okay, so if it starts at 3 p.m. and we go an hour and a half, we're already at 4:30 p.m., aren't we? So that is when we change over from making nuts to making bolts. Okay, so it's going to then make bolts until 8 p.m. Okay, so how much time is that? The difference between 4:30 and 8 p.m., how many hours is that then? So from 4:30 up to 8 o'clock, how many hours is that? That is 8 hours, take away 4:30, so that's 3.5 hours, isn't it? So 3 hours 30 minutes. Okay, so if we want to know how many bolts it can make, then it's going to be making bolts for 3.5 hours, then, isn't it? So if I then say the number of bolts is going to be the number of bolts it can make in an hour, which we were told was 720, multiply that by the amount of time it was making bolts for, which was 3 hours and 30 minutes. So I'm going to write that down as 3.5 hours. Okay, because 3 hours and 30 minutes is 3.5 hours, isn't it? 3.5. Okay, and then tapping that into the calculator, 720 times by 3.5. That comes out to be 2,520. Okay, so that is the number of bolts then it's going to make in that time. So that then is our answer then. It's going to make 2,520 bolts. Two solids J and K have the same density. Complete the table, include units in your answers. Now, do you know the formula for density? Density is equal to mass over volume. Okay, that's the basic formula. So if I know the mass and the volume, I can divide one by the other to find density. So for J, I've been given the mass and the volume, so I can use it to calculate density. 48 divided by 8. 48 divided by 8 is 6. 6 what? It says I need to include units in my answers. So I'm dividing grams by centimeters cubed. So compound units tells me that's grams per centimeter cubed. Or you could, if you want to be smart, write grams per minus power of minus 3. So grams to centimeters to the minus 3. Okay, because you know that a negative index means the reciprocal of. Okay, so it's the same thing as dividing. But anyway, I'm just going to write with a slash. Right, so then we're told that they have the same density, so I can then copy this value over into the other half of the table. So this is also going to be 6 grams per cubic centimeter. And I'm going to need to work backwards to find volume. So I've got density up here and volume down here. So if I just switch those around by cross multiplying, I'm going to get volume equals mass divided by density, then aren't I? So here I'm going to be, I've got a mass of 78 and I want to divide it by a density of 6. What's that then? 78 divided by 6, 13. Okay, then remember I need to include units, so in this case it's centimeters cubed. Okay. Towns P, Q and R are connected by roads PQ, PR, QR. PR is 10 kilometers longer than PQ. QR is twice as long as PR. The total length of the 3 roads is 170 kilometers. Alright, now this is not drawn accurately, so it's not about measuring the distances and using those. I'm going to have to work it out. Okay, I'm going to add these roads in first. They're not drawn, are they? So PQ is the road between P and Q. So let's just draw that in. PR is the road between P and R. So let's draw that in. Oops. Okay, now I'm going to assume that that doesn't actually drive into the sea. And then QR is this road here then. They're not necessarily straight lines actually. It doesn't say they're straight. Okay, so we are told that PR is 10 kilometers longer than PQ, but we don't know how long PQ is. Now, if we don't know anything in maths to start with, then use algebra. So let's say PQ is equal to X. So I'm going to make this one here X. Then PR is 10 kilometers longer than PQ. That makes PR X plus 10 kilometers longer than X. And we're told that QR is twice as long as PR. So PR is X plus 10. So QR is twice that. So it's 2 lots of X plus 10. Now we're told that the total length of the 3 roads is 170. Okay, so what we're going to do is we're going to take our 3 expressions, x, x plus 10, and 2x plus 10. We're going to add them together, and that should give me 170. Okay, so let's just write that down. So I've got my x, x plus 10, and 2 lots of x plus 10. And I know that that is 170. Okay, these were my 3 roads, and this was the total I was given in the question. Okay, so now it's a matter of just kind of collecting like terms together and then see if we can solve this for x. Okay, so let's just remove the brackets over here to start with. So that's going to give me 2x plus 20, isn't it? Okay, I've still got my 10 and my x and my other x over on this side. Right, then collecting like terms together, what have I got? I've got an x, and a 2x. That adds up to 4x. And I've got a 10 and a 20. So that adds up to 30. So I'm going to get 4x plus 30 is equal to 170. So that was all my blue ones. That was all my purple ones. And that was the one I had before. Okay, so 4x plus 30 is equal to 170. Okay, so now I've got a linear equation in x. I can go on to solve it. Let's subtract 30 from both sides to start with. Okay, again, if you're wondering about which one to move first, if you think about what I was saying in the last question about bid mass backwards, it's the same when you are solving these sort of equations as well. You kind of unwind them going through the opposite order that you would do if you were actually working them out. Okay, so that's going to cancel with that, and it's going to leave me with 4x is equal to 170 subtract 30 is 140. And then I'm going to divide both sides by 4, divide by 4, divide by 4. What's that going to give me? So that's going to cancel with that, leave me with x. And then 140 divided by 4 is 35. Do it on a calculator if you're not sure, but I can do that in my head. X is 35. Right, have I answered the question? The question was, work out the length of PQ. Which is PQ? PQ is X. Oh, okay, that's easy enough. Then we have worked out the answer. It's 35. Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees 2 offers for loans. Now, offer 1 is compound interest for 3% per year. And offer 2 is compound interest, first year 1%, second year 5%. Mia says, I will pay back the same amount because the average of 1% and 5% is 3%. Is she correct? You must show your working. Well, only way to find out is to do it. So let's see if we can work it out. So let's have a look at offer 1 first. Offer 1. Now, we want to do £6,000. Okay, now when you're doing interest, I use a triangle FOM, final, original, multiply, FOM FOM, and I'll put my finger on the thing I want to find. In this case, I want to find the final. I know the original and the multiplier. So the final is the thing I want to find. The original is what I started with, 6,000, and the multiplier is, well, it's 3% per year. So if I've got 100%, I want to do a percentage increase of 3%, then that's 100% plus 3%, which is 103%, which is 1.03 as a multiplier. Okay, so then my final amount, covering up the thing I want to find, it tells me what to do with the other two things. So my final is going to be the original times the multiplier, but because it's compound interest, I'm going to raise that multiplier to the number of years that I'm applying it to. So it's going to be 6,000 times, so it's going to be this raised to the number of years, isn't it? Okay, so it's going to be 1.03 squared. So what's that then? 6,000 times 1.03 squared comes out to be £6,365.40. 6365.40. Okay, now offer 2 I'm going to have to do in 2 steps. So final is what I want to find again. Original is 6,000, and then multiplier for the first year is 1%, isn't it? So it's 101%, which is 1.01. Okay, so then again, final equals original times multiplier, which is 6,000 times 1.01, which is what? It's just 6,060, isn't it? Okay, so that's in the end of year 1. So this is year 1. And then in year 2, my final is going to be my original, which was 6,060 now, because it's what I got from the end of year 1, times my new multiplier of 1.05, because it's 5% in the second year. So 6,060 times by 1.05. So that actually comes out to 6,363. So it actually works out a little bit cheaper. So is she correct? No, she is not correct. I think we've done everything. We've got our 2 answers, haven't we? This is the first offer 1, and this is offer 2. We found both answers, and we're saying she's not correct. I think that's fine. Here are 2 sets of numbers A and B. The mean of set A to the mean of set B is 3 to 8. Work out the value of x. Okay, so this is going to be a several step problem. First off, we're going to have to find out what the mean of this is. Okay, and then we're going to use the ratio to find out what the mean of set B should be, and then we're going to form an equation using this information and our answer from the ratio question to form an equation in x, which I hopefully can then go on and solve. Okay, so lots of steps. That's 4 marks. So let's just do it. Okay, so let's think about the first step I said then. So finding the mean of set A. So let's do that first. For set A, mean is equal to, well, how do you find the mean? You add all the numbers up, and you divide by however many numbers you've got, which is 4. So calculator, 200 plus 160 plus 104 plus 100. Don't forget, anything you type into your calculator, make sure you've written down on the paper. Divide that by 4, comes out to be 141. Okay, so the mean of set A is 141. Now we know that set A to set B is in the ratio of 3 to 8. Now we've already worked out the mean of set A is 141. What we want to know is the mean of set B. Okay, so we're going to use what's called the unitary method, which is going via 1. Okay, so it's quite simple. What we do to do the unitary method, we've got 3 things here. If we divide by 3, we'll get to one thing, and then if we take that one thing and we multiply it by 141, we'll get 141. But if we do that to one side of a ratio, got to do it to the other as well. So I'm going to divide by 3 and then times by 141. So what's that then? 8 divided by 3 times by 141. That comes out to be 376. 376. So now I know that the mean of my set B is going to be 376. So let's have a think now about set B. So to find the mean of a number, we take all the values, we add them up, and we divide by how many we've got. So we've got 5 values now. 270, 400, 480, 300, and x. So let's add those up. So 270 plus 400 plus 483 plus 300 plus x. So then to find the mean, we would divide all that by 5, wouldn't we? But we know that that already is equal to 376. Okay? So what we're going to do here, well, I'm going to add up the numbers on the top to kind of collect like terms together. So 270 plus 400 plus 483 plus 300. That comes to 1,453. So the top of my quotient there comes out to be 1453 plus x is equal to, I'm going to take this 5 that was dividing down here, I'm going to cross multiply up there. So I'm going to times both sides by 5 basically. So what's 376? 376 times 5, that comes out to be 1,880. So 1,880. So I've got a linear equation in x now, so I can just take away 1453 from both sides, and it should leave me with x then, shouldn't it? So x is going to be equal to minus 1453. That comes out to be 427. 427. Okay, and that's my answer for x. 427. Yep, I wanted to find x, found it. A straight line has gradient 4 and passes through the point 523. Work out the equation of the line. Give your answer in the form y equals mx plus c. Okay, so we know that the equation of this line is of the form y equals mx plus c, and we're told here that the gradient is equal to 4, and that means m equals 4. So I know the equation already is of the form y is equal to 4x plus c then. So all I really need to do is find c. Now the second bit of the information tells me that my line passes through the point 523. So I can use that information. Passes through 523. So that's the x coordinate there, isn't it? And that's the y coordinate. So if we sub those into the equation, they should work because it's a point on the line, and then the only thing that I don't know there is going to be c then. So subbing those in, so 23 is equal to 4 lots of 5 plus c. What's that? Let's just multiply out those brackets. 4 times 5 is 20, isn't it? So I've got 23 is equal to 20 plus c. Let's just subtract 20 from both sides. It's going to leave me with c equals 3. So now I know all the pieces. I've got m, I've got c. I can write down the equation. It is y is equal to 4x plus 3. Question 29. Two sides of a triangle have lengths 13 centimeters and 27 centimeters. Which of these is a possible length of the other side? Circle your answer. Now, when you make a triangle, if I've got two sides that are 13 and 27, okay, then my last length has to fit from there down to there then, doesn't it? Okay, So it couldn't be more than the difference of these two, could it? So 27 take away 13 is 14. So if it was 14 or longer, it wouldn't actually reach. If it was 14, you'd have like 27 and 13 and 14. It'd be a bit of a rubbish triangle. It'd be kind of a straight line, wouldn't it? Okay, so actually that length needs to be a bit more than 14, otherwise you've got a straight line and not a triangle. Okay, so it cannot be 13 because it wouldn't reach. 13 and 13 doesn't reach all the way across. There'd be a gap in between here, wouldn't it? It wouldn't quite reach. If it was dead on 14, it would actually be a straight line and not a triangle. So it can't be that one. And the other length, again, so the other one I think is too big, the 40. So imagine my kind of 13 and my 27. Then again, this line going between them can't be more than these two lengths added together. So 13 plus 27 is equal to 40. So this 40 can't be a possible length as well, because again you're going to have that situation where your 13 and your 27 makes 40, so you've got a straight line, you haven't got a triangle. Okay, so the only possible one it can be then is that 27 one. Question 30, here is a right angled triangle. Use trigonometry to work out the size of angle X. Okay, right, so trigonometry, first step. Label your three sides: opposite, adjacent, hypotenuse. I always start with the hypotenuse because it's the easiest one to find. It's the longest one. It's always run the one opposite the right angle as well. So that 16 has got to be the hypotenuse. Okay. Now your other two sides you're going to label relative to the given angle, and we've been given X down here. We've been given it to find at any rate. Okay. So the one that is adjacent or next to the X we call the adjacent, and the one that is opposite we call the opposite. Okay, so that means that we have been given the hypotenuse, we have been given the opposite, we have not been given, and we do not care about the adjacent. Okay, so we need to deal with the opposite and the hypotenuse. Now I don't know how you remember this, there's different ways of remembering it, but I remember the trigonometric ratios using the mnemonic SOH CA TOA. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And I'm looking for the one, or the trigonometric ratio that involves O and H. Now hopefully you can see it is this one. It's the SOH. Sine is equal to opposite over hypotenuse. Okay, so we're going to write the trigonometric ratio down for sine, which is sine of an angle is equal to its opposite divided by its hypotenuse. Okay, that's the formula that we're going to be using. Okay, so we're going to sub in our 13 here, we're going to sub in our 16 here. Now the angle X is the angle, so that is the bit that goes there. Okay, so they're the three things that we're going to sub into our equation. So sine X equals opposite, which is 13, over hypotenuse, which is 16. Okay, now we don't want sine X, we want X. So to get X from sine X, we have to do the opposite of sine, which is the inverse sine. So we do that to both sides. Left hand side becomes X, the right hand side becomes the inverse sine of 13/16. Okay, so it's a matter of just typing that then into the calculator. Now to do the inverse sine you need the shift key, shift sine, and then you can just put that in using the fraction key, 13/16, that way you know you've got it right. What's that equal to then? Apparently that is 54.3409 blah 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 blah. We're going to round it off to 1 decimal point, so 54.3 then. And that's my answer. X equals 54.3 degrees. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below. along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.